Hi, welcome to Lesson 6 in our 14-day short introduction to satellite Earth observation. Today we're going to look at the coverage that we get from Earth observation satellites. So these satellites don't sit above us all the time constantly looking at a patch on the Earth. They're in orbit, and most Earth observation satellites take about 90 minutes to go around the Earth, and the Earth is rotating underneath, and so they take some time to collect data over a larger area. It's much easier to see this on Earth Blox if I just show you an example. So what I'm going to do is I'm going to add an area in the Caribbean. So we're going to draw this area over here. I'm going to include some of these Caribbean islands, a bit of Venezuela, and the data set we're going to use, and I'm hoping you're all following along here and doing it yourself. To repeat what I'm doing here is I'm going to look at the Sentinel-1 data. So Sentinel-1 is SAR, synthetic aperture radar. And I'm going to use that because it doesn't have any clouds. I'm going to talk about clouds in the next lesson, but today we're just looking at the coverage. Now, in terms of the time period, I'm just going to look at what happens if we go. So today is the 4th of August. Let's go back to Wednesday and see what we've got in terms of coverage. I'm going to press run. So that's only a few days. That's not enough time to get global coverage on Sentinel-1. And so when we look at the data as it appears on the map, we're going to see that we just get individual strips of the data that's being collected. So we can see that just over the last couple of days, we've got a strip of data here. We've got another bits of data down here. So let's expand the time to, we'll go back to the beginning of the week. We'll see if we get more data. So you see that if we have included a few more days, we're now getting more strips in this area. So each of these strips is composed of a collection of scenes that we can see are composed. So over just beneath Barbados here, you can see an individual scene that's been collected. You'll also notice that there are, with the radar data, you can see the ascending and the descending passes. So some of these passes are when the satellite is going on the upward part of the orbit, and others are when the satellite is on the downward part of its orbit. And notice how they also overlap. So in fact, if we go back a few more days, so let's go back a couple of weeks and add more data, is we'll start to see that these strips of data overlap quite considerably. The adjacent ones overlap and the crossing ones also overlap. The significance here for us, now look, we see we've gone back a few weeks now and we're actually getting a lot of coverage. But where they overlap, it's an appropriate question to ask that, well, on the map layer, what's the value of the pixel? Because there may be, in this area over here, say near Barbados, there may be passes in this direction, passes in that direction. There may be 3 or 4 images that have been collected over Barbados. So what value do you assign to the pixel in your final image? And that's the importance of this block here, the aggregate images in time. So what this block is doing is this is where you instruct Earth Blox how to combine these overlapping images. In this case, we've chosen the mean. So essentially what we're saying is that for every pixel in the final image, use the mean of all of the images that are overlapping to calculate the final value. We've got multiple options here though. You can take the median, the sum, minimum and the maximum. You can also use the earliest or the most recent or the last. And so you can choose which of those pixel values is the one that's in the final image. And that's what this block, the aggregate images in time block, does. Now you have another option here. That's for over the entire time period. But you can see we also have an option to break it down by time period. So by year or month, week, day, hour, minute even. In the next lesson, we'll look at how we can use that to create animated time series. So we can take a longer time period in terms of the collected data, but then cut that into smaller chunks and look at how things change over time.